All right, so thank you. So my name is Rishi Vaish. I've been based here in the Valley, either building, selling, or managing cloud and as-a-service products for longer than I'm willing to admit. And that's what actually brings me to where I am today. I work in the IBM Watson group at the intersection of Watson and collaboration technologies. So that's actually a pretty interesting space and an exciting space for me personally. So what I'm going to talk about today is give you a quick perspective on IBM and AI, share some of our philosophy at IBM around artificial intelligence. I'll dig in a bit deeper into problems that my group is solving in applying AI to collaboration. And I'll also talk about some challenges we see today in the space. Just what are some of the hard problems that we're trying to solve. But before I dig into that, I wanted to do a show of hands from the audience. How many in the audience today are actually practitioners of AI? Meaning you use AI as part of either building a product or... so no practitioners in the audience. OK, that's good to know. My next question was going to be a leading one. It was, do you believe that general AI is achievable? But let me explain what I mean by general AI. Does anybody in the audience, please raise your hands if you think that machines are within a 10-year time horizon going to become intelligent in some way? OK, wow, so there's quite a few people that do. That's good to know. This should make an interesting conversation as well as a panel coming up here shortly. So at IBM, the word that we use to describe artificial intelligence is called cognitive. And it isn't just a buzzword, cognitive. We really use it. There's a philosophy behind calling AI technologies at IBM cognitive technologies. There's three things that we believe cognitive technologies do. One, they understand, reason, and then learn based on interaction with human beings. And when I say understand, I mean understand data sources of a different variety. Understand natural language. That's a problem that I'm personally very interested in solving. Understand images, understand video, understand voice, but also understand structured and unstructured data, and really extract concepts from this data. So one element of being a cognitive system is being able to extract concepts and understand the data that you happen to be working on. The next one is taking those concepts and forming some sort of a hypothesis about it. That's what we call reasoning. So if a system can understand concepts from data, and then it can reason about those concepts and establish some probability about some guesses it's making from the data, we believe that makes it a cognitive system. And the last element is the most important one, is learning. So one has to always close that loop between understanding something from data, drawing a hypothesis, but then interacting with human beings such as yourselves, experts in the field, and feeding that learning back to both the reasoning as well as the understanding. So these three things, understand, reason, and learn, form cognitive systems. But the most important element, I think, in our philosophy here, is cognitive systems are designed to augment human beings. At least at IBM, our mission is not to try to produce a general AI. We have a pretty broad set of technologies, under that banner of cognitive, but we use them to solve very specific business problems. And we're not trying to solve this general purpose AI challenge. I'll give you some examples of where we're augmenting human intelligence. One of the, I'd say, big bets that we've made, or I'd say big challenges we've taken on, is the fight against cancer. So within healthcare, which healthcare itself is a huge, massive industry, cancer is one of the things that we've chosen to tackle under that banner of healthcare. Now, this is obviously like an aspirational goal. It's not something you're going to be able to snap your fingers on and solve really quickly. One of the ways that we use cognitive systems to help in this fight against cancer is as follows. It's a rapidly evolving field. If you happen to be is there anybody here in the healthcare profession in the audience? Raise hands. No, well, so if you happen to be in that cancer field, there's a constant stream of new research that's coming out. And there's dozens and dozens of papers that get published all the time, globally. And a typical doctor, that has to, work in a hospital, take care of patients, can only digest, about 15 odd papers in a month. So between all the other work they do, that's kind of the maximum amount that they can ingest. And yeah, there's a pool of doctors working, so maybe that number grows a little bit. But a well-trained system like Watson can ingest over 500,000 of those research papers in under a minute. I mean, that's like a vast difference in just the quantity of data that can be ingested and understood. From this understanding, the Watson system will draw a hypothesis of what to do if they encounter a certain kind of patient profile. So then it has to understand patient data. This is patient medical data. It could be test results. It could be transcripts of conversations with the customer. It could be notes that someone's put into a medical record field, just note-taking. So it takes all of these and then makes a recommendation in terms of what it thinks the best treatment is for that customer. And I want to be clear here, the idea is most certainly not to replace what a doctor is doing. All the system does is it provides this recommendation, and most importantly, it provides the reasons for that recommendation to a qualified doctor, who then looks at the data and says, oh yeah, this treatment either makes sense, understand why, or they make some modifications and finally treat a customer. There's about half a dozen different types of cancers that we've trained Watson on today, and there's more in the pipeline. And like I said, this is definitely a huge sort of aspirational challenge, a multi-year kind of journey, even to get to this point, and several more years, to go before anyone's going to raise kind of a mission accomplished flag here. So that's just one of the domains where we apply AI. There's many more. One interesting one in field service is, all of us use cell phones. I think if I would do a show of hands, everybody would have at least one or two in their pockets today. Yeah, and so cell phone towers, they're subject to a lot of wear and tear. So how do you automatically detect, whether there's rust on a tower and is it going to fail or not? So we have technology that help process those images and sort of glean more information from there. Financial services, fraud, a huge challenge there. So we have teams that are dedicated to detecting fraud in financial services transactions. And lastly, even security, just network breaches. We all heard about a pretty big breach that happened with a lot of our personal data, systems that can help prevent those kind of breaches. We work on those as well. But again, we're always augmenting what human beings are doing, not trying to replace human intelligence in any way. So that's the big picture IBM. Now to dig into the intersection of Watson and collaboration and conversation technology is something I'm interested in. So I'm going to do another show of hands here. How many people in the audience are WhatsApp users? Okay, good. I'm really glad I don't have to explain WhatsApp. that would take some time. So I on my phone here, I have a WhatsApp group that has 2,000 unread messages. It's a group with some of my buddies, and they've managed to accumulate 2,000 unread messages roughly every 15, 20 days or so. There is absolutely no way, I can keep up with that volume of messages. Now, I would really love to know what's going on in that group, but I cannot bring myself to troll through and find the nuggets that might be interesting, or relevant to me. So the problem we're really talking about here is overload. If you just restrict yourself to conversation streams that you're probably subject to yourselves, whether it's WhatsApp, whether it's Slack channels, whether it's any other messaging software you use, you simply cannot keep up with the volume of information coming in to you. So that's the problem that my group is trying to solve, is this information overload out of conversations. Now, I'm not, since I work at IBM and the B in IBM stands for business, we're not looking at just general consumer type of conversations. We're looking at specifically business conversations. And so one of my charters is to try to understand business conversation. And I think I'll pause here for a second and sort of explain what I mean by understand business conversation. If I were to use the word opportunity in the context of general English language, hey, Meera, what a great opportunity to see you here today. The word has a meaning in the English language, but there's nothing special about it. It's just a good opportunity to meet. If I now shift context and I talk about the sales context, and one of my sales guys comes up to me and says, hey, Rishi, there's a great opportunity to meet this customer today. Suddenly, that word opportunity has a really significant has significance for me. It's probably tied to a record that sits in a CRM system somewhere. It's probably got product line items in it. It's probably got a dollar value tied to it. There might even be a close date tied to that opportunity. Suddenly, just by applying some business context, that word opportunity has become much richer. So that's what I mean by understanding business conversation, is finding these words in business conversations that have special meaning and then associating all of that special meaning with them. And a little more specifically, is to understand what the intent of a given statement or a given conversation is. Is someone trying to buy something? Is someone trying to sell something? Is the intent to hold a meeting? Is the intent to sell a new product? So intent is really critical. So extracting intent from conversation is a big focus for us. Entities, sounds like a bit of a technical term, but all of these objects I mentioned tied to that opportunity, an account, a product line item, those are all entities that might get mentioned in the conversation, and some of them might have special significance for me. So this notion of extracting entities from conversation, is also super critical to the work that we do. And finally, it's also understanding what the topic of the conversation was. If we go back to that WhatsApp group for a minute, I'm pretty sure one of the key topics of conversation in there is a college reunion coming up in December. Now, I'm not going to troll through all those 2,000 messages, but if someone could tell me there's critical information about that reunion, exactly 3 days ago, and you can find a link to register, that would be valuable to me. So it's extracting that topic from a large conversation, which is also a really interesting piece of work that my group works on. So once you've done all this, what do you do with this, the intent, the entities, and this understanding of topics? But what we do is we try to enrich that business conversation. Now, you can imagine, let's go back to that sales domain for a second, and you're having a chat, let's say in a channel somewhere with a salesperson, and they're talking about one of the accounts that you're working on. If there happens to be a critical piece of news about that account that's relevant to the conversation going on, you would want to see that, right in the context of that conversation. So enriching the conversation is something you can do once you understand what's going on in the conversation. The next thing is acting on something in the conversation. Let's say someone says, hey, Rishi, that deal got closed. Well, that's awesome. Someone can go update a record in a CRM system, and you don't have to manually do that. So taking action based on conversation is another one of the benefits of understanding the conversation. And the last one is really summarizing it. Now, I was lucky enough this summer to go back and get a break from work. But when I came back, again, I had hundreds and thousands of channels with unread messages. And again, I was really looking for something that could tell me, these are the actions that were taken while you were gone. Here's a quick summary. These are the things that are open, and you might want to pay attention to them. So this ability to summarize is one of the other missions in this space of conversations. So those are kind of the problems that at least my group is trying to solve. We take the Watson general set of technologies and apply them to collaboration. And I want to now talk about just some of the challenges that we face today. And the first challenge is actually just understanding natural language. It's 2017. You would think that this is a simple problem and it's already solved. But I can guarantee you unambiguous detection of intent from conversation, meaning to unambiguously know what someone said, either if they said it verbally or if they said it in a text message, is really, really difficult. It's removing ambiguity is exceptionally hard. And then you add the dimension. So with IBM, we have customers all over the globe. We actually have rooms where people talk in many languages at the same time. That adds, one more layer of complexity, which is, again, not a totally well-solved problem in the domain of business conversations. And then, another thing that doesn't translate well is things like emotion. We do analyze sentiment and tone of conversations, but getting it accurately is really hard. Is someone angry? Are they being sarcastic? Very hard to tell if you just have text input. We have technology now that looks at facial expressions, also looks at tone in voice and can guess a little bit better. But still, many, many challenges here just with understanding natural language that I would consider to be unsolved today. So those are all, in fact, if anybody knows of good solutions here, have a chat with me. I'm more than interested. The next challenge that certainly my group faces, but I think it's a broader challenge for AI, is explaining the results of AI. I think we had someone here just talking about autonomous driving a while ago. We deal with understanding intent in business conversations. But and when I asked about how many practitioners in the field there weren't that many hands that went up. So I'll spend a minute just explaining what I mean here. A lot of these AI systems are based on probabilities. They take a very, very large number of inputs, calculate some probabilities on them, and then based on those probabilities, make a guess as to what the intent is, what action to take next. It's not always simple, in this world of neural networks and graphs that are like hundreds of levels deep to explain why a given decision point was arrived at. When I started my career in software engineering, again, more years ago than I'm going to be willing to admit, all of this was rule-based. If my system behaved a given way, I could categorically look at the code and tell you, exactly why this happened. If I had a designer working with me, I could present it to an end user in a very natural manner. It was a deterministic system. These new systems, are not deterministic; they're probabilistic. And explaining to someone why a decision was made, I think that's going to be, one of those huge challenges that design teams and machine learning teams, have to solve simultaneously. Not a simple problem to solve. And then, the last challenge is just enterprises. Not all the data is nicely available out there. I work with lots of enterprise companies where just access to data itself is a problem. The data has changed its shape over several years sometimes, and simply connecting to systems becomes really challenging. So just not having access to data, or what people call dark data, is a huge challenge in this space of learning. Learning is fed by the amount of data that you can provide it, and if the data isn't available, it's really tough to learn. The other thing that I find challenging in this space is translating the concepts that you've learned from maybe one industry or one job domain to a different industry and job domain. And like I gave you the example of sales and opportunity. There's certainly a rich set of entities and objects associated with sales. But if I know sales well, it doesn't mean that I know anything about finance at all. I have to redo all of that learning in finance. So when you're approaching companies, this notion of shifting that learning from one space to another is a really hard problem, not a solved problem today. And then if you happen to have enterprise customers, there's one additional dimension that doesn't often get talked about. But you also have to make sure that the learning that you did from one company's data is only benefiting the models of that company's data. In fact, we have to make that commitment to our customers, and we do. And so if you have another customer that might potentially be a competitor of theirs, you have a great model that you've trained based on data from one customer, you absolutely cannot allow the learning to leak into another model. So that's also one of the unique challenges in the enterprise. If you happen to be in the consumer space and all the data is publicly accessible, this part may not be a challenge, but certainly if you're building products for enterprises and you're building them in the cloud, it's a challenge that you've definitely got to solve for. So hopefully in these 10, 15 odd minutes, I've given you a sense that we really have a big mission with cognitive at IBM. All the way from aspirational, trying to help with solving, curing cancer or helping cancer patients, all the way down to understanding business conversations that maybe your sales guys happen to be having. And there's lots of interesting problems to be solved in all of those areas, and we have work going on just across the board on all of them. And lastly, if anybody is interested in connecting with me, here's how to get in touch. I'm more than happy to have a conversation. These are absolutely areas I'm interested in. And thank you very much for your time today.